Yeah, so let's start it.
What is distance x called? Um, don't know.
This is called focal length. The distance from this center till focus is called focal length.
Lenses can be used to form the image of an object. Complete the Ray diagram figure 2 to show how a convex lens forms the image of an object. Um, mm, I don't know where to put the line.
Okay. So in first one, the object, as you can see, the lens is converging the rays towards focus. Like if we take another one which goes parallel to this axis, it will pass through focus. In the second one, it is diverging, right? As the rays goes parallel to this, it diverge, right? Like if we have another ray which passes parallel to this axis, it will go like this. So we can write first lens is converging lens, second
Oh,
is diverging
oh,
lens.
we didn't do number 1.2.
Where is 1.2? Oh, okay, 1 second. Let me erase this and read it. Lenses can be used to form, calculate ray diagram, show how convex lens forms the image, use arrow. Okay, so we have to just make image. Image means where two rays meet. So one ray is already shown. If the object is this and this ray is passing parallelly with this axis, it passes through the focus. Second ray we can pass through the center. Whenever a ray passes through the center of the lens, this ray continues in a straight line without bending. Like it will go like this. Let me draw properly. Sorry, I don't know what's. It will go like this. This is incident ray and this is reflected ray. So they both will meet here, right? If you do it, they will meet somewhere here. So this is our image. Okay, make a arrow and write image. It is inverted because it is going downward, but it is real because rays are actually meeting. Did you do it?
Yeah,
Did you get it? Yes?
yeah.
Okay. Let me erase this.
Give one similarity and one difference between the image formed by the convex lens and the image formed by the concave lens. The convex lens image is not passing through the focal point.
Not passing. Actually, it is passing from the backward direction. But you can write first, let's write similarities. So both of the images are, what are the similarities? This is upright and this is downward, so this is not similarity. Mm, as the object is upward, this is downward, so no, this is difference. And what else is the both are passing through focus, but one both image are no, this is diminished. So when you made it, did you use ruler to make it? Because in that case you will exactly know what is the size of image.
No.
Okay. So basically in concave and convex, mainly we get smaller object than smaller image than object. So you can write both images are smaller than original object. Because if we pass it like this, it looks like bigger, but I'm not sure if we make it using a ruler. Let me try it here. I can use a straight line. So straight line passing through this. Yeah, as you can see, if we pass through this, at this point they are meeting, right? So this image
Yeah.
is smaller than object, and in the second figure you can see image is this is the image which is smaller than object. So similarity is both images are smaller than original object.
Mm-hmm.
And then differences are that concave lens form upright image while convex form inverted image. You can see image is in the upright, like in the upward direction in case of concave, but in convex the image formed is in the downward direction, inverted. This is called inverted, and that one is called upright. That is the difference. Okay.
Yeah. The person uses a lens to read the letters on the back of a coin. The image height of the letters in the on the coin is 9 millimeters. The magnification produced by the lens is 6. Calculate the height of the letters on the coin used for this equation sheet. So magnification. Magnification equals image height over object height.
Yes, image height over object height. Use this.
So the image height is not is what you want the object height
Yes, we want object height.
equals image height divided by magnification.
Yes,
So 9 divided by 6
yes.
equals 1.5
Yeah, 1.5
millimeters.
millimeters. That's correct.
What piece of apparatus would have been suitable for measuring this wavelength? Percent ruler.
What piece of that is what we use? Yeah, ruler.
Write down the link which links frequency, wavelength, and wave speed. V equals F. The wave y. Calculate the wave speed. Wave speed equals frequency times wavelength. The frequency is wavelength is 80 centimeters, but you need that in
Convert it into
meters.
meters. Yeah.
So 80 centimeters is 0.8 meters.
Yes.
And then frequency is 55, I think. Is it 55?
45.
How is it 45?
Yeah, it's 45. 55 times zero point 0.8, right?
Oh, 55 times 0.8 equals 45 wave speed.
Yeah.
The frequency of the signal generator is increased. This makes the wavelength of the wave change. The wave speed stays the same. Describe how the apparatus could be adjusted to show one complete wave without reducing frequency. Um,
Yeah.
taking a picture.
Um, by moving the wooden bridge, by increasing the distance between vibration generator and the bridge, and by making
By
string longer.
increasing distance between vibration generator and string
And the bridge.
and bridge. Student wants to investigate how the speed of a wave on a stretched string depends on the tension in the string. Student uses the apparatus in figure 4. Describe a method the student could use for this investigation.
Hmm.
Um,
Figure 4 is this. So this is the setup. So
you could increase the tension on the string by adding more masses.
yes, he can vary the tension by adding more masses, and then which create standing waves, right?
And
Uh,
more mass to pulley to increase tension on the string
and the
to
formula is,
investigate.
because he is putting more mass, so how he will calculate tension using this m times g, right? Mass times gravity. Using this, he can calculate, after putting mass on the string, he can calculate tension, and by different masses he will get different tensions.
Yeah,
Then he will turn on the generator and adjust the frequency from here, and then the stationary wave will form, and then he will measure the wavelength, right, which is the distance of the loops. This will give, this is the wavelength, right?
mm,
And from signal generator he will get the frequency, he will record the frequency. And if we have frequency and we have wavelength, we can calculate the speed using this formula: speed equals frequency times wavelength. And then he will repeat it by adding more weights to change the tension, and repeat the process to see how speed changes with different masses and tension, right?
yeah.
Okay, next.
Driver of a vehicle sees a hazard on the road. The driver uses the brakes to stop the vehicle. Explain the factors that affect the distance needed to stop a vehicle in an emergency. Road surface increases brake distance due to having less grip and friction
Hmm.
to slow down the car. Another is the thinking distance
Yeah.
of the driver on how long it takes for driver to respond to X. emergency, and then there's tire tread, there's frictional grip. You stop with uh, write down the equation with distance, force, and work done.
Hmm.
Distance, force, and work done is work done equals force times distance.
Yes, that's correct.
The work done by the braking force to stop the vehicle is 900,000 joules. The braking force is 60,000 newtons. Calculate the braking distance of the vehicle. Equals braking distance equals work done divided by force.
Yes.
So work done is 900,000 divided by 60,000. 15.
Yeah, the answer is 15 meters.
Greater braking force, the greater the deceleration of the vehicle. Explain the possible dangers caused by a vehicle having a large deceleration when it is braking. Lose control.
Yeah, brakes could overheat and it can cause car to slip, right?
Cause car to lock up when the brakes get too hot or they use too much of the brakes will lock up and this causes the rear wheels to stop moving
Yeah, we can say that.
and the car will spin out. Control. Figure 5 shows a solenoid with the magnetic field of the solenoid on figure 5. Explain why the iron. Oh, that's.
Magnetic field will
Um,
pass like this, right? You can just draw magnetic field lines like these, right?
yeah.
So you can just
Explain why the
imagine
iron.
it goes like this, north, and they make like this from north to south pole, right?
Yeah.
So the direction is going to be this.
Then why iron rods move apart when switches close. When switch closes, current flows through and a magnetic
Rods
field
become magnetized.
due causing rods to become magnetized
Yeah, and they repel each other.
to repel from each other. Student measured the strength of electromagnet as the maximum weight the electromagnet could hold. Explain why the method used by the student is not valid for this investigation.
Hmm.
Um, Number of turns in wire, turns in wire on the ankle, current.
Again, multiple variables are being changed here, right?
Yeah.
at the same time. So whenever multiple variables are being changed, we cannot see the effect of each properly. That's why it is invalid. So therefore impossible to determine effect of either variable and it's invalid.
How does increasing the current in the wire affect the strength of the electromagnet when an electromagnet has 30 turns of wire? 30 turns of wire. The current, when current increases until 2.5, weight increases.
Yeah, until it reaches the maximum value, right?
Yeah. How does increasing the number of turns of wire from 10 to 20 affect the strength of the electromagnet compared to increasing the number of turns of wire from 20 to 30, 10 to 20? 10 to 20 is a much larger increase in current,
Yes,
a
then
much
20
larger
to 30.
increase in weight.
There is much larger change from 10 to 20 tons than from 20 to 30 tons, right?
Mhm. The
Next,
light from distant galaxy shows redshift. Complete the sentence. The term redshift describes the observed increase in the of the light from a distant galaxy. Concentration of the light from a distant galaxy.
it's wavelength, right?
How does the Big Bang Theory describe the universe when it began? That the universe continued to expand.
Hot and dense. It was hot
Okay.
and dense.
Describe how the relationship between the speed of galaxies and the distance from galaxy is from Earth. As distance
Yeah,
increases,
directly proportional.
the speed increases directly proportionally. Which of the following is the same as 6 times 10 to the power of 12 terameters? Is
So
terameters is 10 to the power minus 12 or something.
it's plus 12. So 12 is
Oh,
already there. So 6 times 10 to the power 12 is already there. And it has 10 to the power 1 terameters means 10 to the power 12 meters. So we will times it again by 12, which will add up to 24. 12 plus 12, 10 to the power 24. So it's D, last option.
the day in Figure 9 supports the suggestion that the universe began from a very small origin, and the universe was a small distance away from Earth.
Yeah, galaxies further away are moving the fastest, right?
Yeah.
So let me see. Okay, I think now we can continue next class. Okay. Do you have any
Yeah.